For those that don't know, I'm Mike Bauer. I'm the CTO of Arcurve, and thank you for joining us today for our AI 101 presentation. Format we'll be using today is a 30-minute presentation followed by Q&A with our intent to wrap up a few minutes before 1 so that we're not going over time in your lunch hour. We're confident there'll be lots of great questions that will easily take us to that time. In terms of questions, we will be using the Q&A feature built into Zoom. So on your bottom taskbar down there, you'll see a Q&A window you can pop open. Please post questions there. We'll do our best to answer those in the order they come in and to answer all of them within the time we have available. That may or may not be possible. We'll see how that goes. Today, I'm pleased to be joined by Mike Morley and Peter Tunkus. Mike Morley is the Director of Artificial Intelligence and Machine Learning at Arcurve. He graduated from the University of Waterloo with an engineering degree and has worked in numerous industries. And one of the things I really appreciate about Mike and working with him is he's equally comfortable in the field and in the head office. And this just really gives him a lot of good feel for data and what's happening with processes. One thing I've noticed with Mike is that he's most at home when he's working with data that have a direct connection to a business process. And of course, also when speaking at conferences or to the community about AI and ML, graph databases in particular. So if you ever want to engage Mike on something, just engage on graph databases and you'll have a great conversation. Peter Tunkus is a data scientist with our Arcurve Advanced Analytics team. He has a PhD from Ohio State University, and he's worked in academia and industry across North America and Europe. He has a deep understanding of statistical and machine learning approaches. And one of the things with Pete and being on our team, that just is so fabulous is that academic and research perspective and that rigor that he brings with it. So we're really thrilled to have Mike and Pete here with us. They represent some of the breadth and the skills that we have, and they've got a great presentation in store for you. So with that, I will turn it over to Mike Morley to begin the presentation. Mike.
Thanks, Mike. Yeah, so today thanks for taking the time today. One of the things we're particularly interested in doing, and there's machine learning and artificial intelligence, they're very, very powerful methodologies, powerful techniques, and they can bring a lot of capabilities to your respective organizations. And we'll talk about some of this as we go through this. But there is a lot of, hype out there. There's a lot of noise. There's a lot of things that kind of distort the value perspective from the context of, what's actually possible with the technology. So something we'd like to do is level set this a bit and go through a little bit of the history of AI and ML and talk about where these things have come from, how they've emerged, how they've evolved, and then use that as a foundation with which to discuss and frame that up in the context of actual applications to industry and various businesses and whatnot from our experience. And when I started out in this domain, it's actually been fascinating going through the process of setting this lecture up. Back when I started, I was very fortunate to start my career at an organization called the Noranda Technology Center. And it was a place in Montreal where the Noranda group of mining companies at the time had set up an advanced research facility in Montreal. And it was an amazing place to work because there was all sorts of incredible research going on at the time. And this was coming in when I was in university, and I worked there after university as well. And one of the fascinating things that we were doing is we were actually working with earlier versions of some of the methodologies that you're seeing now in the context of constructing complex mine models for doing finite element analysis of rock mechanics bursts and all this sort of thing. And it was really incredible stuff. And I loved, this 3D thing was fantastic to work with. A lot of really interesting challenges. Part of what I did there was actually writing a three-dimensional blast design system in conjunction with some of these other bits of software. But the really interesting thing was, as is the case now, the challenges weren't so much with there are certainly challenges with the algorithms and making them function correctly and whatnot, but the actual larger challenge was getting the data together to actually feed into these things. And that part to me at the time was a lot less exciting, because it was, it's just the stuff, that's just the data, that's just the data. And the person who's quite a visionary who's running this whole project said to me, he said, Mike, these algorithms and everything, they're great, and they will continue to improve and get to be more powerful and whatnot. But 30 years from now, we are still going to be fighting with the challenges associated with getting the data together to feed these algorithms. And he was absolutely right about this. And it's fascinating to me that is indeed the case. And we still face challenges with respect to bringing the data together and getting that stuff in good shape in order to then put it into the models and whatnot. So that's why, with respect to this particular slide, in the introduction to this lecture, is want to do a little bit of level setting around the terminology and also around what's required to pull some of this stuff off. And you'll notice that we're using a building metaphor here. And the reason we're doing that is that the foundation of all of the various different algorithms, where they're talking about, more traditional analytics, data science, or machine learning, they're all based on the fact that you need to have data to bring into these things. And the good news about it, which we'll discuss a bit more as well, is the fact that there's a tremendous amount of data inside of all organizations that are out there that is not currently being fully leveraged. And the nice thing that's happened in the last 10 years, in particular, in the last 5 years, is that it's become a lot more possible to bring disparate, siloed, and complex data sets together and actually work with them, put them into a data lake. Once you get these things into the data lake and get that stuff sort of framed up, then you can start to do the analytics piece on it. You can start to count things in a smart way. Once you get that sorted out, then you can start getting into the data science elements. And I think Pete has some thoughts on that aspect.
Yeah, for sure. So jumping off from what Mike's saying here is that, ultimately, with the ability to explore and analyze the data once they've been collected and made accessible through the data lake or data warehouse, however you have that set up, right? Introducing a data science practice can take this to the next level, right? And it influences not only the subsequent layers, so like climbing to the top of the building there, but also our foundations as well, right? So really, the idea behind the science of data science lies in taking the problem statement, project goal, research question, and ultimately generating testable hypotheses, right? So from determining whether there is a relationship between two things, so thinking about action to outcome, let's say, to determining the best approach to achieving that goal, right? And so this means determining what kind of analyses help paint the picture more clearly. Is an AI ML approach even appropriate to meet the business needs? Are there other data sources that we can leverage to meet those needs? And so, ultimately, if we step back, all of this involves critically bringing together business context with data understanding. And so this kind of introduces an iterative process in which we start to learn more about the data as we develop our business understanding and vice versa.
Yeah, thanks. And of course, the top of the pyramid, the top of the building, as it were, the penthouse, I guess, is the objective that was originally outlined by Marvin Minsky and those folks around AI being something that's whose objective or goal is to simulate human intelligence with machines. And our thoughts on this are more that there's actually a bit of a different way of looking at this, where you can use these methodologies to augment people's abilities as opposed to seeking to replace people. And it's really fascinating when you kind of go back in time and look at this in the context of through the lens of history. You see this sort of pattern that it's emerged out of all of this, where you get this, this perception of what the technology is capable of versus what the actual reality of it is. So this goes all the way back to 1804, when there was a device called the Jacquard loom was created. And this was a very early version of essentially punch cards. What they did is they had a sheet that was fed into this automated loom that would have the patterns on it to drive the machine to actually create various different types of textiles and automate that whole process. So of course, as soon as that started to happen, that immediately begat Luddites, who were terrified by the fact that now these machines were going to take their jobs. And then you get this perception in popular culture that emerges out of this interplay that starts to arise. Frankenstein being an example of a book that was written on the that was derived actually fairly directly from the whole experience around machines and electricity in particular, and fear of those things. Going into things like the Turing test, the classic experiment that Alan Turing proposed, that then in popular culture that generates this image of the metropolis being an example of that from the 1920s, where you had this dystopian class war driven by technology, in which the machines are used to replace people's livelihoods and whatnot. That got accelerated somewhat as well with the Minsky conference that happened, where the term AI was actually coined. And immediately following that, there's a machine that was created, just as one example, called the perceptron. The perceptron's machine, it was an early version of an image classification system, and it was designed for image recognition using about 400 photocells connected to the neurons to actually make predictions about what an image was or was not. And the New York Times at the time reported that the perceptron was going to be the embryo of an electronic computer that the Navy expects will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. And it was also quoted in the New Yorker that this machine is going to be the first serious rival to the human brain ever devised. And of course, in popular culture, then you get the movie 2001 with HAL, and of course all of the hypotheses about where that was going to go with respect to the interplay between humans and machines. Now, reality, of course, did not live up to the hype. And the perceptron machine turned out to be a very, very limited thing. It was limited by the technology that was available at the time. It was limited by the data that was available, and it was limited by the actual boundaries of the algorithms that they were working with. So there was quite a big, what they call the AI winter, that happened from that, from sort of the early 1970s, so 1974 through into the 1980s, when we started to see a resurgence a little bit as the machines became more and more capable at the upper end. So the big things like the Cray 1 and some of the large IBM machines that were around at the time, those machines started to make it possible to do things like expert systems. So these are sort of deterministic, rules-based engines that were used for various different medical diagnostic applications and things like that. They were also still very limited, though. And it was sort of a combination of really a few things that led to where we are now and the acceleration that we've seen over the last number of years in the world of AI and ML. So the first was the advent of the personal computer, which this machine you see behind me was actually my first computer. So I'm an example of a person because of the fact that these personal computers became widely available during the 1980s. Compared to prior to that, you had to actually go to a university. The University of Waterloo, where I went actually at the time, had what they called the pit, which was a big pit full of these huge, machines like the ones that were more commonly or not commonly available, but that was the only way you could access the computers. The personal computer made it possible for just about anybody to get involved in learning how this stuff worked. Then you had the rise of the internet and the World Wide Web. This enabled the mass contribution of data and the assembly of the large volumes of data that are essential for training the algorithms and whatnot. First example of that really, of course, in the public consciousness was Google and the PageRank algorithm. That then was accelerated even further once we got things like the iPhones, the computer in your pocket with all the sensors on it and everything else. That then enabled the mass contribution of photographs and images that act now as the training sets. So this has led to basically the dawn of the golden age of AI, the place where we are now. And it really has been created by these different factors that I listed and was just describing in the history there: computing power plus connected data plus the advent and emergence of talent due to the much more widely availability of computing platforms, and then mobile devices and sensors. Now, of course, at the technology company end of the spectrum, these are organizations that you obviously would be familiar with: Microsoft, Facebook, YouTube, Google, Netflix. These sorts of companies are essentially, they live in this world. They were the ones who have emerged from all of the data that's out there. And there's a really great quote by Hillary Mason, who's a researcher based in New York, actually. And I was fortunate to meet her at a conference where conferences were still a thing. And she made some really interesting points about this, where the best AI is the AI that you're not even aware is there. So just to use Netflix as an example, there's a really great use case that Netflix has set up in the context of AI and ML and the way they use these sorts of the combination of the algorithms and the data and whatnot. And that is that when you're looking at your profile, what they'll do is they'll scan through all of the movies that are kind of that they have in their database, and they'll use a person's interaction with the Netflix engine plus demographic data to actually customize specific images to advertise which movies you might want to consider to watch next. So if you look at my Netflix profile and you compare it to my wife's profile and you look at sort of James Bond movies, I actually get different pictures compared to what she gets. She gets a lot more Daniel Craig pictures than I do, just as a specific example. Google Maps is another one that does some really interesting stuff in terms of routing and traffic optimization, where they actually compute and they factor AI and ML into helping people avoid traffic jams and whatnot. And I think, Pete, you had some examples here as well.
Yeah, I mean, if we kind of think about it, right, like thinking about that timeline, so Google uses the PageRank algorithm in combination with a couple of other things to, tailor your search results, or, things like Google AdWords based on your website visiting history, recommender engines like what you get on Amazon when you go shopping, and that kind of thing. And honestly, we can tie all this back to our building metaphor, right? Like it's all about leveraging the data that are available. And there's a lot of that, right? But not just leveraging the data, but using them in a way that's digestible to then achieve goals or solve those problems. And a lot of what these big players do might seem complex, but fundamentally, everything they're doing is built up from and off of an iterative progression of experiments, applications, tools development. And really, ultimately, we can find applications of AI and ML used by industries and sectors everywhere, including around us and in our backyard, essentially.
That's actually, thanks, Pete, that's a great lead in. So Rio Tinto, the reason I put them up there is they've done some really interesting things in the context of bringing a lot of the methodologies in, and they created what they call the Mine of the Future project. And you can look this up. It's actually really something you should check out. There's lots of great information out there about that initiative. Their objective was to get one of their mine sites in Australia running with full autonomous vehicles by 2012, which they accomplished. And then they went on to automate the drill rigs and automate they've got an automated haul train now. They're working on automated shipping, autonomous shipping. And it's really great to see this, because I think that was another thing that we found that's really interesting about all this that Pete has also mentioned, is the fact that because of this continued acceleration of technology, the platforms that are required to do this have been democratized quite a bit. So it used to be that you had to be a Google or a Facebook or a YouTube or whatever to be able to leverage this sort of thing. That's no longer the case. There are lots of really great technology platforms out there that have brought the cost of and the complexity of this down, and the cost of and complexity of bringing the data together down quite a bit from what it was even a few years ago. And this continues to accelerate. And so we've actually done projects, and we'll just highlight a few here, with organizations that range from fairly small ones to some larger ones as well. For example, we were doing a student cohort analysis with a school board in Saskatchewan. And the challenge there, of course, is as many of you may know that if you have kids, is the report cards have changed over the last number of years, where they went from being sort of, I have a 72% or a 50%, which you don't want, obviously, to being much more sort of descriptive in the way they use text as opposed to deterministic grades, which presents a challenge in terms of how you do year-on-year cohort analysis. If you make a change to a program or something, how do you figure out how the students are actually doing? So we set up a system that pulls data together into a graph database and then does some manipulation of those data to try and extract and then move those grades into a more deterministic frame, so that then they can actually understand impacts to the student body as they go along. And Pete, I think you had some examples here as well.
Yeah, and so if we take a look at our little matrix here of AI in the backyard, right? So some of these examples are like Mike's school board example, fairly industry or sector specific. But in a lot of ways, again, like I was saying earlier, a lot of these applications are really generalizable, right? So, like a couple of my favorites that I like to reference when talking about this sort of thing is, marketing and sales, right? That's important almost across the board, whether you're talking about B2B, B2C, things like that. And so AI and ML is being used right now among companies big and small to discover patterns or segments within a book of business, or a sample or universe of prospective clients and customers that really might not be obvious to target at first blush. So really, this approach to segmentation is used to confirm or generate things like customer or client personas based on the variety of data that are on hand, makes targeted messaging a lot more straightforward and focused, helps facilitate marketing campaign strategies and effectiveness. And stepping back to a more holistic view, those kinds of AI or ML applications in the marketing space make the task of examining where the business has been, where it is now, and where it's planning to go next, that much more efficient. We can provide a similar story when it comes to customer experience, right? Again, thinking about a lot of B2B and B2C type businesses, there are plenty of tools out there like Merits or Qualtrics to collect and organize survey data, but applying AI and ML tools can really take that to the next level, right? So for example, right, we may be interested in some of those structured scores like customer satisfaction, overall satisfaction, or net promoter scores. Well, AI and ML can be used to kind of, in a similar fashion to what's happening with, the change in grades among school systems and school boards, that we can provide a more holistic and rounded out understanding of customer satisfaction by using some basic techniques in natural language processing, so text mining, text analysis, to provide some added context to what does a 7 on a 10-point scale for satisfaction mean, right? And so that gives us a better idea of what the customers are actually saying, so a better insight into the voice of the customer than is captured in just those measures or those numbers alone. And we can take this a step further, again, leveraging the data and the wealth of data really that's on hand, right? To take a look at customer experience and then putting that side by side with other business metrics, right? Because the question is, what does CX, customer experience, mean for my business's bottom line? And so it's definitely possible with the kind of technologies that we have today, along with the techniques, to be able to put those things side by side to find out, if in fact, improving some element of the customer experience will actually have some kind of a return on investment. And we know that even back in a few years ago in 2018, Gartner had conducted a survey across organizations in Canada, US, UK, Australia, and a handful of other countries, found that 93% of respondents were attaching some kind of ROI metric to their customer experience improvement projects. So I had a lot of fun working on a similar project not long after that survey came out, in which the business was able to really promote and strongly promote not just a customer first approach, but a customer first / company also approach. So it's definitely possible, again, like I said, across companies big and small, to be able to leverage AI and ML to as a not just a strong and effective, but also highly accessible set of tools to make those decision-making processes a lot easier and a lot more efficient, which in turn gives a lot more confidence that those decisions that are being made are the right ones for stability and growth.
Yeah, thanks, Pete. And there's a couple things that I can just build on there too. So that's there's really great examples there. And one of the things that we're really excited about is the fact that there are all these what we would consider to be underutilized data assets that exist in organizations. And again, the really big opportunity these days is not sort of necessarily with like startup companies and this sort of thing. It's not with the big, those big technology firms. It's the fact that every organization out there has data assets that are sitting there, and these things are underutilized. They're assets that could be taken and leveraged and turned into value for organizations. And it's become much more possible to actually make this happen these days with the way the technology has evolved. Just to use a couple of other examples here. For many firms have all kinds of PDFs, whether you're talking and documents, where there's all of this unstructured data that's got tremendous potential value associated with it, that's sort of trapped in these large file repositories that many organizations have. And of course, the reason for that is the cost associated with trying to get these data out is often beyond, even thinking about it, until recently, in which now you can get, and we've actually gone through this process of taking large numbers of PDF files, environmental impact assessment reports specifically, and having AI agents go through these things looking for various patterns. And they can say, oh, we want to try and find documents or pages in these documents where there are high incidences of terms associated with chemistry, signals associated with that, so that then we can detect tables that exist in those things, and then we can use AI agents to actually extract the data out of these tables and then get that data back into a state where it can then be used for downstream analysis. So that's, and there's all kinds of really interesting ways that these data can be harvested and leveraged that were not even possible just even a few years ago. So there's a tremendous amount of potential there that I think organizations can now start to harness and leverage the assets that they have. And particularly in this area of connecting more traditional analytical models where you've got deterministic values. Let's say you've got a rock crusher system or something to that effect that's running, and you want to try and figure out utilization, maximize utilization and minimize downtime. Well, you can now bring in addition to the weightometer and sort of the more traditional time series based data that you typically use for deterministic analysis of failure modes of a system like that, you can now bring in things like work tickets and how people were, job description or descriptions of things that people were experiencing as they were trying to address issues with these sorts of machines. Was it cold out? Was it what skill sets did the people have? And you can bring these things in and then actually couple those with the analytical data to then generate new perspectives and look into things in ways that were not possible even a few years ago, to determine root cause analysis of why something may be failing. And this kind of leads us into, what is possible? Where is this stuff going? So we really believe there's a couple things that we, based on our experience in this domain and the history that we've had with it and over the years and whatnot, and seeing sort of what works and what doesn't. Very much right now we're at a state where these methodologies are extremely powerful, but they are limited. So if you train a model based on a set of data and whatnot, a machine learning algorithm, whether it's a predictive thing or a clustering thing or whatever, they are limited by the data that they have. So it's not like a human intelligence where you can take a human and you can put them into a different set of circumstances or different contexts, and the human will kind of figure that out and be able to respond to it. The current versions of these ML systems, they are specific to the actual data that you feed them. So that's why you see situations where different types of classifiers are specific to the thing that they're trying to accomplish. So you can't take a classifier trained to identify, potential cancer incidences on mammograms and apply that to recognizing wildlife. You need to have two different classifiers for those cases. We believe, though, that going forward, that the models are going to become increasingly flexible and they'll start to become much more adaptable. Although I don't believe that we're close at this juncture to realizing the goal of simulating human intelligence. We believe that it's intelligent augmentation of human processes is where the value lies, as opposed to trying to replace people with artificial intelligence. So that's where we really see this idea of human-machine symbiosis. These more advanced and sophisticated algorithms and machine methods working in conjunction with supporting and accelerating and augmenting people's abilities to do things better. It's bringing new capabilities to the equation, is what that's really all about. Another thing we're really excited about is this idea of reality becoming the UI. So, and we see this a lot with our colleagues in the architectural space, where the environment that you're in, instead of kind of seeing everything through all these screens and sort of having the barrier between you and the data, that starts to dissolve. And I'm not talking about those things that you stick on your face. Those have, I think, a fairly limited utility. The thing that's much more exciting about that is actually bringing and having the environment that you're in respond to you as a person or you as a group of people. through sensors or other sorts of things that actually then allow the environment to change and adapt itself to your requirements. And of course, knowledge augmentation is the one that I'm really personally very passionate about. That's the graph database stuff. And I actually do collect all the articles that I read and everything else into a graph database, and I use, we experiment and run models on that to actually cluster and group things and go, hey, Mike, you've got 10 minutes available. Here's 3 articles on a subject that you're interested in that you may want to study, while you've got that time available to you. Pete.
Yeah, and so I think thinking about this again holistically is that it's really hard to give enough emphasis to the fact that application and implementation of all of these ideas, right? So going beyond what we've talked about so far, in terms of what's happening right now, but for a lot of these sort of futuristic prospects, what's coming down the pipe here is that the development, implementation, application is all iterative, right? So like if we want to think about, reality becomes the UI or human machine symbiosis. How many of you remember or perhaps even use some Google Glass, right? So that's one example of, the use of, one's surroundings in order to create data and to, interpret the world in an augmented fashion, right? And to the point about bulky goggles and things, right? I think that's a great example of this sort of iterative process too, in that virtual reality has made its appearance before what we have today with Oculus and the PS4, Xbox systems, right? I don't know if I'm dating myself too much, but how many of you remember Nintendo's Virtual Boy, right? So it's that similar kind of concept that it happened like the perceptron. It was interesting and it signaled a lot of interesting things on the horizon, but it just wasn't quite there yet. So and indeed, as far as any other examples, right? This is happening all the time, and there are articles coming out every other day with new stories, right? Like Spotify, I heard on the news a couple of weeks ago that Spotify's been working together with a number of universities and institutes around the world to augment their recommender engine for what kind of music you should listen to, not just based on your past listening history to introduce new genres and things, but to use things like speech to text and other vocal cues to suggest mood music, right? So in other words, turning your emotions and your moods into data points, right? And so that's again where where we can again start think about not just like the principle of okay, well there are these fancy computing methods to get us towards our outcome, but again fundamentally, right, what are the data that we have? What are the data that we're using? And in this case, right, things that we might not ordinarily think of as data points actually could be, right? So these are all works in progress. They're all very iterative. There's a lot of work to do, but again, I think the sort of bottom line that underlies a lot of this stuff is that it's not really inaccessible anymore, right? Like the research that's on the cutting edge now is falling into ordinary practitioners' hands, right? Whether they're working for a business or just playing around privately. It's falling into their laps, like not long after these things come out. So.
And speaking of, computers reading your emotions, I'm sorry, Dave, I can't do that. Yeah, hopefully it won't get to the point where they start throwing us out airlocks, but that gets into a whole nother lecture that we're going to plan on the subject of in the future here. So at this point, I think we'd like to get Mike back. Oh, there he is. And we'll start getting into the questions.
Hey, thanks, Mike and Pete. That was fabulous and super interesting. We've got a couple questions that have been posted here. We'll get to those. I have just one of my own I'd like to throw out in there, and I think it's really cool that you've highlighted the use of NLP, natural language processing, and the processing of textual, like text documents, unstructured data. I mean, my perspective has always been, from that, numbers guy, the engineering background, right? You have to have hard data, but being able to extract data out of unstructured data and loose documents is I think fascinating, and it's probably an underutilized resource that exists in every large organization. One of the things we'd talked about previously, and you touched on it briefly here, Mike, was a project that you were involved in where you're looking at downtime optimization and trying to understand downtime characteristics of, I believe it was a rock crusher. And when you described that in a bit more detail to me, you talked about looking at hard data, operational data, actually measured data coming off the machine, but then also combining with temperature data, environmental data, some textual processing and such, just to gather a whole bunch of different data sources to help come to a conclusion and really understand what was happening, and make a recommendation to the company that, that allowed them to achieve some business goals with that. And the one thing that struck me about that is, there's almost, I understand that you have to at some point pull in disparate data sources, or maybe, some orthogonal data sources might not be obvious, and you have to try and find a correlation there. But is there a danger at some point of, you can't analyze everything? You have to maybe add more data into the mix to find the correlation, and you can't, what's the sweet spot? Too little data, too much data? Do you see any patterns, any advice for anyone who might be, looking to go down that path to how to maybe tune that and find the bowl of porridge that's just right, so to speak?
I think Pete described that pretty well. As it is very much so. There's an iterative process, and it is a process of one that's really working through starting with the initial question and then working through the questions that come out of that. Often what ends up happening is the first question that you might have is not necessarily the most interesting one or the one that provides the most value. So a lot of times what we'll see is one of these projects will start up and it'll start off with a fairly specific ask. It's like, oh, can we do this? Can we, our hypothesis is that the rock crusher thing is being affected by the weather. Stuff, it's cold out, it's wet out, stuff clumps together, rock crusher isn't as efficient. That was an example of a hypothesis. As you're going through these processes, though, what you tend to find is that when you start bringing in other data sets, or when you start deepening the investigation, you start to uncover insights you may not expect. And a really important thing when kind of embarking on one of these things is not to try and become overly fixated on a specific outcome. You got to really kind of keep an open mind, because what you'll find is you may end, almost always we've found that you always end up in a different place than you started with an analytics project like this, like these. And a really interesting, actually, adjacent example of that was I had the good fortune to meet David Misa, who's the director of knowledge architecture for NASA, who was part of the inspiration for some of the stuff we were doing in these other domains in terms of bringing these unstructured data sets in. And they were doing exactly this with the International Space Station, where they have all the telemetry that comes in, like the traditional analytical stuff that comes in from, all of the devices that are inside of that environment. But what they did is they had the astronauts, of course, make logs of how they're doing and what's going on, and very much like the work tickets or health and safety H&Is, hazard identification patterns that exist in most energy and environmental companies around town here. So their inspiration is what they did is they combined those two data sets. So they used some NLP methods to then correlate those and extract sentiment out of what the astronauts had written down in all these, hundreds of thousands of log files that were text-based, and then blended those data together with the detailed time series-based telemetry data coming off the devices. And by doing that, they were able to then affect and understand the way the environment was affecting the astronauts' moods, and therefore how the astronauts were interacting with the devices, and therefore also affecting the downtime. That was actually where the inspiration for that other project came from. So we started pulling in the work logs and looking at how those correlated to unplanned downtime incidents. So it was that kind of curiosity and that juncture between those two things that really led to the more interesting outcome.
Yeah, thanks, Mike. And I think your description of the iterative process and the learning, the unknown becomes known, and you learn, and it's a journey. It ties in with a question posted by Marcel Pretot here, and I hope I'm pronouncing that right. Apologies if I'm not. and his question is, would your team expect to see organizations start to organically grow and apply such capabilities? Or would we first expect to see these capabilities emerge as embedded components, capabilities in third-party components, business software and such? I'll give my answer, and then Mike and Pete can refine or build on it. Correct. But my take on it is I believe it will depend on your area of specialization. So third-party components, we tend to see often they are organized around a specialty of labor or some specialized knowledge. And so they will, of course, bring in AI, ML techniques in their area of specialization. If that happens to be an area that you can use and incorporate, you'll then, of course, use them. I believe where companies will start to grow and build their own expertise is in their area of specialization, where they have, so to speak, their own secret sauce. They understand the data, the space, and so on. And they have their own unique knowledge and perspective and data that they can apply to that space. So I think, I hate to sound like a consulting answer, it depends, but I think it's actually a broad answer, and it's tied to the domain knowledge and the particular expertise you have.
Yeah, there's a really great seminal paper by Douglas Engelbart. So he's the guy that is mostly known for inventing the mouse, but he did many, many things beyond that. And his thesis was very much on this notion of augmenting human capabilities, augmenting the human intellect. And the thing that I found very insightful about reading his work was exactly like you're saying, Mike. Like what ends up happening is you do have this domain specific thing that occurs. So if you're talking about bringing AI and ML capabilities into an HR system or into a project control system, for example, or something like that, certainly the software organizations that are out there are going to do this. But what ends up happening, and they are doing this, what ends up happening though is that the domain that you exist in starts to frame and shape the data very specifically into the context of that domain, right? So, and this has always been the struggle with these sorts of systems that I'm sure everybody here has experienced in the sense that, I've got this project control system and I'm trying to look at my data in a different way, or I'm trying to correlate it to something going on out of the skills database that I've got in this other place, or I'm trying to relate it back to my clients that are in my CRM system. The problem is that all of those software companies, they want you to use their thing to do all this stuff, which actually isn't really possible because your businesses all have their own context and way of thinking about the data that is not in any of those systems. And it's trying to force that into the shape. It doesn't work very well. So what we're seeing more of now is this idea that you have a bit more of a neutral platform that is brought into companies, things like Databricks, or I think there's a question about differences between data lakes and databases, which we can answer, I guess, in a bit here. But just to allude to that, there are lots of really useful platforms out there now that allow you to unify data from these different sort of spaces where they're stored, the transactional systems, HR systems, CRM systems, and so on. Project those into a form that is modeled in the way that your businesses think of their data. And that's super important because that way you can then start to generate insight that is very specific to your industry, and then you can bring to bear the deep and rich knowledge that the people in your organizations have. And that's where you really get the awesomeness out of this stuff. And Pete, I think,
I'm just going to, it's fabulous. I was going to segue to Pete here anyways, Mike. And I was hoping that number one, Pete could address the data lake and database question that's out there. What's the difference between those two? But I think that data lake database question also flows nicely into another question, which is, what must companies put in place? What needs to be in place in order to start down the path and to developing an AI solution or coming up to speed on AI and ML technology? Pete?
Yeah, sure. So I'll start off with the data lake versus database question, and then I'll address the how do you get started question, because I think that also ties into Marcel's earlier question as well, in terms of like, do you implement something on your own? Do you use third parties, right? But anyway, so regarding data lakes and databases, and I'll throw data warehouse in there as well too, just to kind of mix it up a bit more, is that essentially like a data lake is just essentially an unstructured repository, right? So any and all data will go into your data lake, right? So that means that the data could be structured in a specific fashion. They could be unstructured, so really just like toss in a bunch of PDF files and text and that kind of thing. Whereas a database or a data warehouse, right, as sort of a one step further beyond a data lake is that those latter two, right, the database, data warehouse, they tend to feature oftentimes structured or somehow filtered data and tables, schemas, that kind of thing, that have already been processed for some specific purpose. Now, that doesn't mean that whatever you find in a given database or data warehouse is ready for any, out of the box analysis, right? There's still, part of the data sciencey exercise, right, that we data scientists tend to put ourselves through, for better or for worse, is that 80% of the time that we're doing things, we're not writing neat machine learning models or AI models at all. We're really cleaning and preparing data and putting it together. So even in the situation in which you have a somewhat curated data warehouse or set of databases, it's still not quite ready yet. But again, data lake ultimately is just you're throwing everything in there, and it's pseudo centralized location for whatever data you might want to use at some point down the line. And I think, did you have anything to add, Mike?
Yeah, I think that, I guess on that one, the other thing we're seeing a lot of on that front too, it's, I mean, I'm a big fan of graph databases for that particular use case. So you basically bring your data together and use that plane. But there's a number of different platforms out there that are extremely effective at doing this, like Databricks is one. And I think Microsoft's got one called Synapse that's quite nice. Snowflake's another. What we're also seeing is that there's a convergence also in the context of the analytical piece of this. So, this idea of a database, a data lake, and the analysis engines, they're all kind of actually converging a bit. The way we look at it is we don't think of these things replacing any of the systems that you have currently. They augment them. That's another really important point, is you're basically projecting or bringing aspects of the data, whether it's structured systems or out of PDF repositories or whatever you have. And you're adding this analytical layer on top of it. So it's a yes and thing, as opposed to, oh, you have to replace this thing with that thing kind of an approach.
And so, and I think that makes a pretty good segue then into, what does it take to get started with this, right? And to Mike Bauer's point earlier, right, is that whether you want to do something in-house or use a third party, it really depends on a lot of things, right? Not just in terms of the technology, but also in terms of the business needs and that sort of thing. But ultimately, right, to kind of answer that question holistically, like how can businesses implement data science, AI, ML, right? We can kind of think of it as like a hierarchy of needs, if you will, right? And so when we think about it that way, right, a good sort of intro is even our metaphor that we have with the building at the beginning of our presentation today, right? Where you have to have those foundations, right? So you have to be able to collect, store, and access the data. That's foundational. You can't do any of this without that stuff. But the next step up is where, again, like I was mentioning, the data scientists spend most of their time, right? Exploring and transforming that data. It can sometimes take a lot more time than you think. But again, I think it's fair to say that more than 80% of the work we do as data scientists is allocated to cleaning the data, uncovering anomalies, and prepping the data for use, right? And so, once we have that ability to explore and transform, that's when you can start putting together those clean data sets for use by folks in the business intelligence divisions, data analysts, or any other end users, including ourselves as data scientists, as consumers of those data, to start testing out those hypotheses. And it's at that point that you can then implement things like, A/B tests, experiments, simple ML algorithms. That becomes a facilitated possibility. And taking what we learned from our learning optimization exercises, then you can, start to look forward to the ability to test and apply AI techniques. But again, it's all about that foundation, right? You have to have those sort of initial structures. Do you have the data? Are those data accessible, right? However that's set up, right? And that will depend entirely on the business's needs and that sort of thing, right? And I would just add that it also goes a little bit beyond the technical work as well, right? Because when you do have a data science or an AI, ML, or even like a generally speaking, a technical IT project, I think it's important to work on or develop a project management framework to ensure that things will get delivered on time, right? Because we're all interested in that. But also that we're working through the iterative process involved with data science, AI, and ML in such a way that is at least structured to the extent that we know where we are in the project stream, right? So a pretty popular framework that I particularly like a lot is called Crisp DM. I'm sure many of you have probably heard of it. But what that particular framework does is that it emphasizes the importance of iteratively building up business and data understanding to facilitate the data explorations and analysis, modeling, evaluation, and finally implementation, right? So as you're working through all of these stages, you're constantly updating your business understanding and data understanding, right? So when the question comes up like, do you have too much data or too little data? That's what you would find out based on correspondence with business partners and stakeholders to see, hey, are we including things that we shouldn't be including, are based on the business context, or vice versa? Are we not including things that we should? And then see, well, do the data provide us with information that's useful vis-a-vis what our business partners are telling us? If we don't have those data, is it possible to find those data, or can we come up with a proxy for those things, right? So again, it's all very much iterative. But those are the kinds of things to think about if you're wanting to set up this type of AI ML practice, regardless of what scale it is that you're wanting to apply. And then same thing if you're going to be looking at potential third-party or out-of-the-box tools, right? Do those out-of-the-box tools or third parties, can you work with them? And is it possible to be able to achieve that kind of confluence between data understanding and business understanding? That's really important to make sure that whatever it is that comes out of this whole process, so some kind of predictive model, let's say, that it's actually useful, right? That it's doing what you need it to do.
Great, thanks, Pete. We've got quite a number of additional questions coming in, and we're short on time here. So
trying to answer one of them here.
We're trying our best to answer a couple online.
Great questions. I like this.
Yeah, they're fabulous. There was one that came privately, just asking about what skills would lie between say the IT department and the business department, and I'm just going to answer that in a really high level and really simply, that it because of the exploratory nature that Pete and Mike have talked about, it really is a mix of skills, right? You need the business involvement to understand what are the questions and hypotheses that will have business impact, and you need the technical side to do the exploratory bit and iterate on that back and forth. There was one really good question about from Aaron Hillier here. Well, they've all been great questions. Sorry, but a question specifically from Aaron Hillier here about are there areas where ML and AI pose a risk or are misused? And yes, definitely that is a risk. I'm sure Pete and Mike have more detail they could provide on that. What I would suggest time-wise here is that we can take a super quick stab at that, but connecting with Mike and Pete on LinkedIn might be a really good way to continue the conversation. And then, of course, there's also the info at Arcurve if you'd like to contact Arcurve about anything we've talked about here or for any reason. One thing I will throw out there quickly on the ML and AI, if you haven't looked at GPT-3, which is Pete can maybe give more detail on what the acronym stands for, but it's a trained model built by a company out of San Francisco called OpenAI. If you just Google it, you'll come up on the Google page with some references there specifically to the healthcare or life critical, where there's some danger in using it. Pete, I think we have like 1 or 2 minutes. I don't know if that's enough time to do anything justice, but if you had any thoughts you wanted to throw in there on the risk of ML AI.
Yeah, no, I definitely like to. I think that's a super, super important question. And it's become ever more important as a lot more of these kinds of fancy neural network type models start getting tested and implemented to various degrees, especially by a lot of these big players like Google and Facebook and others, right? So I mean, with GPT-3, right? So GPT-3 is it's known as the generative pre-trained transformer model. And essentially what that is you can think of it as like a text generator, right? So it takes information about, what's, let's say, crawling the web or Wikipedia articles, New York Times articles, and a plethora of other text-based sources to be able to generate text based on a given prompt, right? So you can kind of think of it as like a super ultra advanced type of chatbot, if you will. But I'm hand waving a lot with that. So I encourage anyone who's interested to find some articles and that sort of thing about it. It's really interesting stuff. But to get to the question about, are there areas where ML and AI pose a risk or are misused, right? I think, and I'm going to use this term fairly, like, I really don't mean to be glib about it, but in a lot of cases, we can think about this in terms of like the flexibility or lack of flexibility of some of these advanced techniques that are emerging nowadays, right? And that is that ultimately, right, garbage in, garbage out. So the problem with a lot of these models is that if we take, for example, what I mentioned, that Spotify is researching the use of emotional cues to create a more advanced recommender engine based on mood music, right? Well, does that take into account different cultures, right? So how we might intonate and how we might speak and act, right, when we're feeling upset versus when we're feeling exuberant is going to be different here in Canada than it might be in Japan or in India or in Central African Republic or wherever, right? These things might be used by people all around the world. And so it doesn't take into account those kinds of cultural differences. And so as a result, those models are or can be inherently biased, right? So ethics plays a serious role. And so it's really important that, companies, especially that are at the forefront, are keeping these kind of AI ethics in mind, right? I mean, I think there was a big debacle about image recognition not too long ago on Google image searches. And I'll let y'all out there, well, ironically, Google this if you'd like, or use Bing or Yahoo or whatever you want, right? But you can look up the stories about this. It's quite crazy. So I think it's really, really important, and it is problematic. I think it's something that as like humans, we're still trying to figure out and work through, whether we're here in Canada, in the States, in Europe, Asia, Africa, wherever.
And there's that could be a subject for ethical AI. It's actually one that I have done presentations on in the past, but it's something I think that would make a really great lecture in the future on the subject as part of this series.
Yeah. So I'd like to just formally end here. We went a couple minutes longer than we had planned. I didn't want to run right to the end of your lunch hour, but we have. I know that the actual webinar is scheduled to run a few minutes longer. If people are interested in further questions or chatting, I'm happy to stick around if Pete and Mike are as well.
Yeah.
But that's really just kind of a bonus random tack on at the end here. So thank you everyone for attending. We look forward to seeing you at our next event. And I think, Mike, your comments on intelligent augmentation are very fascinating and might make a really good topic. Thanks, everyone.
Who respects lunch hours? I think there was so Douglas Adams, you talk about somebody who's brilliant with respect to making predictions about how well this stuff works. Like if you ever, I don't know how many people have read the Hitchhiker's Guide to the Galaxy, but there's a wonderful segment in there about, bistro math being the foundation of a machine learning method to make spaceships to figure out time-space continuum calculations. There's another really beautiful section in that particular book that talks about how they teach these elevators to figure out, and this is actually stuff that's weirdly, we actually were looking at a project that is reminiscent of this in a weird way, where the elevators would actually be trained to make predictions and to be able to see into the future and make predictions about where people would end up being on floors. And of course, this made the elevators very depressed because they could only see so far into the future and they didn't like where the future was going. We actually did have a project we were looking at, ironically, where we were going to use facial recognition-based cameras to count people getting into elevators in old buildings. So buildings that don't have more sophisticated or more recent heat control systems. And of course, what was happening is the buildings in question were set up in such a way that they'd have to run the heat and the cooling systems at a fixed state, regardless of how many people were in the structure. So what we were looking at doing, and this is kind of before the whole COVID thing made everybody go out of the offices, which put the project on hold, sadly, but hopefully it'll come back again. Essentially, the game was you'd put these cameras on it, which would count people getting on and off the elevators. It would know which floors the people were on. You'd have temperature sensors on the floors, which would then help the people running the facility to adjust the temperatures appropriately.
Neat sounding project, Mike. All right, I think we've answered all of the questions here. So and a large number of folks have dropped off. So I think we'll call it a wrap at that. And look forward to seeing everyone at our next event.
Yeah, thanks everybody for
time.
Yeah.
Thanks for attending.
Yeah. Thanks for attending. Appreciate it.
Great questions too, for sure.